Hello everyone, welcome to the Microsoft Azure Networking video series. In this short video, I'll try to explain to you about the Azure Load Balancers. My name is Önder. I'm a Microsoft Azure MVP and I work as an Azure Solution Architect. The Azure Load Balancer delivers high availability and network performance to your applications. The load balancers distributes inbound traffic to backend resources using load balancing rules and health props. Load balancing rules determine how traffic is distributed to the backend. Health props ensure the resources in the backend are healthy. The load balancer can be used for inbound as well as outbound scenarios and scale up to millions of TCP and UDP application flows. There are two types of load balancers, public and internal. A public load balancer maps the public IP address and port number of incoming traffic to the private IP address and port number of the VM, and vice versa for the response traffic from the VM. By applying load balancing rules, you can distribute specific types of traffic across multiple VMs or services. For example, you can spread the load of incoming web request traffic across the multiple web servers. An internal load balancer directs traffic only to resources that are inside a virtual network or that use a VPN to access Azure infrastructure. Front-end IP addresses and the virtual networks are never directly exposed to an internet endpoint. Internal line of business applications run in Azure and are accessed from within Azure or from on-premise resources. For example, internal load balancer could receive database requests that need to be distributed to backend SQL server. When you create an Azure load balancer, you will select for the type of the load balancer. You will also select the SKU. The load balancer supports both basic and standard SKUs, each differing in scenario scale, features, and pricing. The standard load balancer is the newer load balancer product with an expanded and more granular feature set over the basic load balancer. It's a superset of basic load balancer. SKUs are not mutable. You may not change the SKU of an existing resource. A standalone virtual machine resource, availability set resource, or virtual machine scale set resource can reference on one SKU, never both. There is no charge for the basic load balancer, but the standard load balancer is charged based on the number of rules and data processed. By the way, as you see in the slides, standard load balancer has support to availability zone and has some SLA, but when you go to basic load balancer, you will not have SLA and you cannot use the availability zones. To distribute traffic, a backend address pool contains the IP address of the virtual network interface cards that are connected to the load balancer. Backend pools are configured from the backend pool below. For the standard SKU, you can connect to an availability set, single virtual machine, or a virtual machine scale set. The load balancer rule is used to define how traffic is distributed to the backend. The rule maps a given front-end IP and port combination to set of backend IP addresses and port combination. To create the rule, the front-end, backend, and health prop information should already be configured. Load balancing rule can be used in combination with NAT rules. For example, you can use NAT from the load balancer's public address to TCP 3389 on a specific virtual machine. This allows remote desktop access from outside of Azure. Notice in the case, the NAT rule is explicitly attached to a VM or network interface to complete the path to the target, whereas a load balancing rule need to be. By default, Azure Load Balancer distributes network traffic equally among multiple VM instances. The load balancer uses a 5-tuple source IP, source port, destination IP, destination port, and the protocol type hash to map traffic to available servers. It provides thickness only within a transport session. Session persistence specifies how traffic from a client should be handled. The default behavior is that successive requests from a client may be handled by any virtual machine. You can change this behavior. A health prop allows the load balancer to monitor the status of your app. The health prop dynamically adds or removes VMs from the load balancer rotation based on their response to a health check. When a probe fails to respond, the load balancer stops sending a new connection to the unhealthy instances. There are two main ways to configure the health probes, HTTP and TCP. After explaining brief information about Azure load balancers, let's do some demo. So I have a resource group and I can create my demo environment in this resource group. So first of all, I will build a virtual network for my VM. So I'm going to create a virtual network. And my virtual network name will be lab VNet, and it will be in the East US region. You can change the IP address range, or you can keep default one because this is just only demo. So I'm gonna use 192.186.0.0/16, and I'm gonna add some subnet. This subnet will be my cap subnet, and the IP address range is 192.186.1.0/24. And I'm gonna add the second subnet. This name will be DB. This time I'm gonna use 192.168.2.0.0/24. Okay, I'm ready to create virtual network. And I deploy it. Okay, my virtual network is ready. Let's look at, and the subnet are ready too. Okay, now I can create my availability set. I'm gonna put my application VM in this availability set. So let's say this availability set is app availability set, and it will be in the East US. For default, domain 2 is okay for me, and update domain 5 is okay for me. I'm going to use the manage disk. So let's go and create availability set. After, I need a network security group because I will have some application server, and I need to expose port 80 to the internet. Okay, availability set is ready too. So let's go back to my resource group, and I'm going to add network security group. Network security group. Name will be app NSG, and it will be in the East US. Okay. Now I can deploy my application servers. So first of all, let's create a Windows Server 2016, and it will be in my lab demo resource group. So name app VM01. The region East US, and the image Windows Server 2016 data center. You can change the size, by the way, or you can use default one. For my test environment, I'm going to use T4S version 3 and my username, password. So I'm going to open RDP port for now, or maybe let's say HTTP2. One OS disk enough for me. And in the networking phase, I'm going to use my LabVNet and I'm going to use my app subnet. I don't need public IP address for now because I would like to create load balancer and I'd like to use load balancer public IP address. And the network security group, I already have network security group, which is at NSG. So I'm going to use this one. I don't need accelerate networking. For now, I don't need load balancing, but later I will create load balancer, and I will attach to VM to the load balancer. So let's go to management, but we forgot to choose availability options. So let's go to availability basic section and the availability options and choose the availability sets. We have availability set in here and I choose my availability sets. So let's go to management. Okay, let's create a diagnostic storage account for me. Let's go. And create. While creating the first VM, let's deploy the second one. So this time my VM name will be fvm02. Region will be same, which is East US, and the operating system Windows Server 2016 data center, and the size will be same. D4S version 3, and availability sets. I'm going to choose my existing availability set and my username. And password. Let's go back and choose RDP and HTTP. Yep, I'm going to use virtual network, this virtual network and this subnet, but I don't want public IP again. Network in security group, I have already network security group. I don't want accelerate networking and management, advanced review, and create the server. By the way, first VM is already deployed. As you can see, when you go to VM, you can see the VM is working properly. And VM has a private IP address, but has no public IP address. So let's go to networking. So it's the VM is using the existing application, existing network security group, but this network security group has no any rules. So let's add some RDP access. For now, normally you shouldn't open any to any. For now, I'm going to allow RDP access to this VM from internet, from everywhere actually, and I'm like to allow 80 port from internet. As I said, normally you shouldn't allow from any to any. You should only add from specific IP address or specific protocol or specific port. So I think my second VM deploying still. So let's go to resource group and create one public load balancer. So at this time, I'm typing load balancer. Second VM is ready too. So my load balancer name app LB, and the region will be East-US. Yes, my load balancer type will be public because I would like to use some, public IP address. And the SKU, you can change the SKU, basic or standard. If you go to standard, the basic is free, but if you go to standard, you have to pay the, some money, depends of your rules. I mean, load balancing rules or not rules. The benefits of the standard SKU standard SKU has SLA, and you can use some availability zones. But for now, let's use the basic one. It will be a public load balancer, so I have to create public load balancer. I have to create IP address, public IP address, and assignment, let's say static. I don't want to use IP version 6. So let's create the load balancer. After creation finished, we have to define some backend pool, health probe, NUT rules. Maybe we need to define some load balancing rules. It's already configured. Let's go to load balancer and let's check our front-end IP. You can see my front-end public IP address. Let's go to backend pool and add to VM to this backend pool. Let's say app LB backend pool as a name. Virtual network lab VNet and associate to virtual machines at. So I can associate these two. And click add button. Okay, backend pools are ready. So we have two VMs in the backend pool. So let's go to create health probe or check the VM's health. So let's say add LD health probe. So I'm gonna check the VM's AD port, and this health probe is work every 5 seconds. And if the health probe gets unhealthy threshold consecutive 2 times, so it will redirect the traffic to another VM. So, okay, let's add this one. First of all, I need to access the VMs over RDP, because after accessing, I can install some IAS, and then I can create a basic website in these VMs. When I complete the applications or websites in the VMs, I can expose the AT port to the internet. For accessing VM over the RDP, I have to create inbound NAT rules. So let's create one of them. So let's say RDP app VM01. This is my front-end IP. So service, I'm going to use RDP. Port number, I'm going to use, for example, 6666. Target virtual machine at VM1. And this is the first VM at VM1 IP address. And I'm going to use port mapping and target IP 3389. So this is my first inbound NAT rule. So when I try to access to this IP address with this port, NAT rule will be work, and it will route my traffic to the first VM with this port. Okay, let's create the second NAT rule. This time name will be RDP at VM02. Front-end IP will be the same. Service will be RDP. This time port number 6667. Target virtual machine at VM02. And this is my public. This is my internal IP address for my target virtual machine. And port mapping will be custom, and target port will be RDP port. After completing this one, let's try to access VM. For this, I'm going to use remote desktop connection manager. So let's delete my existing VMs in here and then add the server. So my IP address for the first VM will be this one, but I'm going to use 6666 for RDP port VM01, and logon credential will be under display. Okay, so let's add the second one. IP address will be the same, but this time I'm going to use 6667 for RDP port at VM02 logon admin under, and display settings. Okay, scale. So let's check if it is finished or not. Yes, almost finished. So let's try to access. For the first VM, I can go to first VM, and the second VM, I think still deploying. Oh, no, okay, it's ready to. Same IP address, but a different port. I can access to the VM. So let's create a basic website in this VM. I would like to I'm not recommend, but for my demo environment, I would like to off my firewall, internal Windows firewall, and I'm going to local server. Okay, and let's add the IS web service. server and install. And I'm doing the same things for my second VM. Okay, and let's go to local server and close or turn off EA enhanced security configuration. And let's add to IS role, web server IS. We can install, no, this is just demo environment, but we can install by default. Okay, it's complete for my first VM. So let's go to IIS, click to my server. Default document will be index.html. Okay, and let's go to my www root folder under C drive, inetpub www root, and let's create a one text file, and the file name extension will be not index, of course, it must be index.html. Let's change later. So let's go to insight and let's say devcloud.com. And okay, so let's try internally. Okay, for the first VM, IS is working and the website is working. Let's go to second VM and do the same things. Click the server and go to default documents and change to my default document as index.html. And let's go to C drive, inetpub folder and www root folder. Create a one text file. Actually, I can copy from the first server and pass to the second one. So let's try the second VM and let's go to localhost. Yep, and the second website is working too. Now I can expose my websites to the internet. For this, I'm going to go back to my load balancer and I need to create one load balancing rules. And let's say add. So my load balancing rule app rule, and I'm going to use the IP version 4. I'm going to use my front-end IP protocol TCP, and the port will be 80. Backend pool, I have already backend pool, and I can choose this one. Health prop, I have already health prop. If you want the session persistence, you can choose, but I don't want now, and I'm going to keep the none. And let's say okay. After updating finish, I can access to my website from this IP address. Or let's go to this IP address and add some DNS name to this IP address. So let's go to my resource group and let's go to my public IP address for my load balancer, and let's go to configuration and change the name. Let's say dev cloud ops, and my DNS name will be devcloudops.eastus.cloudapp.azure.com. It's a little long, but I can use this DNS name. By the way, if you have already a custom DNS name, you can change this DNS with your custom DNS name. So let's go to, by the way, rules completed. Let's go to my sorry. Let's go to new tab and write devcloud ops dot. I think I write devcloud ops dot eastus.cloudapp.azure.com. Yep, my website is working. So let's shut down the VM, one of the VM, for example. Actually, we can test like this. Let's go to index.html on the first VM, and let's rename it index.txt, and let's go to app VM 01 and change to extension again, HTML, and I'm going to fvm2. This time I will add this VM's name. So VM02. Okay. Okay, so let's open my browser, for example, incognito, yep, and type my DNS name. Let's try it. It's going to fvm1. So let's shut down the fvm1. So after 1 minute, actually not 1 minute, I think 10 seconds, because interval was 5 seconds, and my load balancer will be try 2 times. So if my load balancer cannot reach to fvm1, it must be route the traffic to the fvm2. Let's try. Yep, let's go to fvm2. So my load balancing is working, and my website is working properly too. So we complete the demo, and thank you for everybody for watching my video. And if you would like to reach me out, you can reach me over the Twitter or LinkedIn. So you can write me or you can ask me anything about the Azure. Thank you so much, and see you in the next video.